has this do notation, which actually is the odd one out here, because instead of being a declarative thing in an imperative environment, it's the other way around. It introduces a way to sort of cause side effects. The main point here is I need only say what I wish done. So we sort of make a little language where we force away all the craft. Embrace your inner lollipop. So this is willingly going against the advice of Alan Perl in this case. He's the inventor of small talk, by the way. So Perl helps you do this. It's already full of DSLs, and the only difference between Perl 5 and Perl 6 is that Perl 6 formalizes the notion of a sub-language of it.
That's the only difference?
In this case, that's the only difference. There are a few other minor changes that we snuck in. Actually, if we think of a sort of graph with awareness on one axis, this is not Turing completeness, by the way, because Turing completeness is pretty useless in measuring the relative strength of languages. Most languages are Turing complete, and that's all you can say of it. So this is a sort of more fuzzy measure of how expressive or how powerful is the language, and it's subjective. So if you think something is positioned wrongly on this axis, it's you who is wrong, not me. And then we throw in another axis just to have two dimensions. This is the amount of stuff we put into the language. So we have Perl up here, which is deliberately orthogonal and with lots of stuff and very expressive. And then we have things like autocomp down here, which has a lot of craft but is not very expressive. And Prolog and lambda calculus and perhaps some variants of Lisp end up here, being very simple in idea but extremely expressive. And I thought of this and couldn't find a programming language which belongs in the fourth corner. You're very welcome to propose one, but Fortran, well, the sad thing is Fortran is probably quite expressive still and has a lot of stuff. So, HTML, yeah.
That's down the bottom.
Right, yeah. I was thinking YAML or something, but the thing is, down in that corner, we're not talking programming languages anymore because they are not expressive enough, and they mainly just sit as shown in this graph. What is it down there in the corner? Well, it's single quoted strings, both of them like this. And they have very, very little behavior. They mainly have this backslash escaping, not much more. And the next one up is substitutions. And as it happens, character classes in grammars. They actually turn out to be the same sublanguage. And then the next one is double quoted strings, has a bit more awareness, a bit more behavior. Actually, you can embed arbitrary POSIX code in POSIX double quoted strings. So they are, in that sense, they are equally powerful as Perl. In practice, you don't use them as a programming tool, you just use them as a nice way of getting improvements. And then up there, the three up there basically tie, actually. Regexes and signatures in Perl. There are parentheses around signatures because they're not actually a sub-language in POSIX, but it seems to me that they might well have been, because so many... They sort of are, yeah. Formally they are not, but...
they have their own parsing rule.
Oh, they do, yeah. But that doesn't make them a sub-language.
It doesn't make sense.
Okay. Well, so the parents might or might not be needed. And you see here that they basically follow a straight line. Actually, the deviation from the straight line here might be due to my subjective opinions. But it's not so strange that things with a lot of stuff in it, the stuff is there to make the programming language more complex and more expressive and more useful in general. I have
an example of my own to show?
of a sublanguage, which is not one of these. And it's an example of the 8 queens problem, which, as it happens, the queen in chess is derived from a piece originally called the vizier, and still called the vizier in Hungary and Turkey and some other countries. So this doesn't feel extremely off topic actually. It's a chessboard. And the 8 queens problem is, here you're given 8 queens. We took them from 4 different chess sets. They all threaten each other, and your goal is to put them on the chessboard such that no queen can see another queen, no queen threatens another queen. So here's one possible solution, and you see immediately with your better eye that no 2 queens are on the same row and on the same column, and here's somehow to show that they are not on the same diagonal either. So let's switch modes and think about how to write an algorithm to output all the 92, as it happens, solutions to this problem. Well, one data model we can choose, which is sort of obvious, is for each row on the board we make a for loop and we nest them, and we print the solutions inside, and we have to have a way of calling this. But let me just note that already this is quite intolerable at this stage, and it's only the beginning. So we're sort of longing for a metaphor here. A metaphor loop. So we can write 8 for loops without 8 levels of indentation. But it gets worse, because we have to we have to provide the conditions so that they don't end up on the same column. So this is a lot of next if. I don't know if you can actually see this small code, but you're not meant to. You're just meant to feel the pain of it. A lot of next if that control that each new value is not one of the old values. Could have used junctions here, but then would have been less painful, which counteracts the argument. And then it gets even worse because we have to add the diagonals as well. And this is very sort of regularized code, and unless you are some very particular breed of masochist, you shouldn't be writing this out longhand. I actually had a generate this. A couple of years ago, I thought about this 8 queens problem, and I solved it with recursion very nicely in Perl 5, as it happens. And then, just for fun, I golfed it down to 2 lines. But now I'm thinking of doing something else, that is creating a sublanguage which is tailored to solve this kind of problem, the kind of problem where you have a bunch of values and they should satisfy a bunch of conditions. So we start with just eliminating the for loops and saying we have 8 variables here. You notice immediately that this is not correct Perl 6, but it's sort of a variant. Instead of a type, which we can put between the my and the variable, put a range there. So we say this variable can go between these values. And the for loops are implied. So once it has tried all the values of one variable, it jumps one step out and tries the next value of the previous variable. And then we enter the preconditions, and here it's already a bit much to write, so we start thinking about ways to shorten it. You have both column restrictions here and the diagonal restrictions. The column restrictions are easy to eliminate. We just say that we have a module called, or a pragma called use distinct, and we use that, and we can eliminate some column restrictions. And the diagonal restrictions, we have to sort of find the pattern there. So the first thing we do is rename the variables to just $1, $2, $3, and so on. And that's legal in Perl 6, but it's legal in the sublanguage. It doesn't have anything to do with the match variable $/. Now that we have renamed them this way, we can parameterize the names. So you see here dollar and then brackets. So we calculate the number that we want to refer to. And then suddenly it gets all regular. You see this whole map up there and all map down there. They're basically the same, just different in different numbers. So we can put everything into here's your meta for loop. This is it. Because the implicit for loops are inside, and the outer for loop is basically just for generating the 8 for loops that we wanted. So this is a nice short solution written in a sublanguage made up while trying to solve the problem. And I have a module that does this, which converts the code down into real Perl 6 and runs the Perl 6. Surprise, it's very slow. I think I aborted it, but estimated the time to about half an hour for solving things, which made me want to write it in Perl 5, but then the problem is that inside the where clauses, I use arbitrary Perl 6 code, and that wouldn't be possible without very much work with Perl 5 module. But it works, yeah. And then I thought further, would you make this into sublanguage? Imagine just writing up this as a problem and getting the result. That would be pretty cool. For those of you who don't know this kind of problem, the letters actually stand for distinct digits. So you have, for example, 2 M's here. They're supposed to be the same digit, and you're supposed to find out which one. So we could translate this theoretically into this program in my sublanguage. And here we have a couple of new features which I will omit, such as forward references and private variables. Another travesty of real Perl 6. And this just gets translated ahead to the nested for loops again. The problem is solved slowly, but still. So Perl 6 killer feature, if you ask me, is having declarative pockets in a program where you can do whatever you want. It's just tailored 100% to your subproblem. And since they are declarative, they can be optimized away to the sublanguage's own preferences. For example, this one could theoretically be reduced, and is reduced on the Wikipedia article of this program, to just actual values. It logically deduces everything, and that's definitely possible. My module doesn't do it, but I guess it could. And the exotic control flows, such as the for loops that you saw here, and sort of implicit next things everywhere, is just great to hide those in the cracks of the syntax that you're using. So making an exotic control flow feel natural, that's the thing we're after here. Sublanguages, among slangs, called by Perl 6, or lollipops. We want to hand out lollipops to the programmers. And Perl 6 radiuses are just an example of this. A very good example, to be sure, but it shows what you can do when you tailor a sublanguage to one particular problem domain. And we'll see much, much more of this. By the way, old joke, I know. How many programmers does it take to change a light bulb? Anyone? Oh, not an old joke. No.
Yeah.
Yeah, Larry knew. I'm showing this because it's sort of a jokingly good example of when you get too little information from a failure. If you get a failure, your next natural question is most likely, but why? I wrote everything right, why shouldn't I get out the answer? But Prolog, at least many implementations, just say no or false or something. Saving yourself. That part. Prince of Persia, The Sands of Time. So the Prince of Persia franchise got a reboot in 2003 by Ubisoft this time.